In yesterday class, we have discussed the definition of a random process, random variable, a sample space, event, all those things discussed in the last class. Today, we will see a few more important concepts. So, you can observe here three definitions. The one is PMF, PDF, and CDF. Probability mass function, probability density function, and cumulative distribution function. These three things are very essential in model number 1. Let us see what you mean by a probability mass function. Here the definition of it is written. Probability mass functions are used to describe a discrete probability distributions, right? So probability, which is in the nature of a discrete, such a probability distribution is described using a probability mass function. Probability density function, the probability which is in continuous nature, such a distribution is described using a probability density function. PMF, it is related to a discrete probability. A PDF, it is related to a continuous probability. You can see here cumulative. The definition of it is given. It is always increased in quantity, always adding a previous data and present data, cumulative addition, continuously. So that is called as a cumulative distribution function here, right? So all these three things are discussed in today's class. PMF, it is related to a discrete probability. PDF, it is related to continuous probability. CDF, a CDF of a PMF is available, a CDF of a PDF is also available. Then how they are totally related to each other, that will be discussed, right? We'll see a cumulative distribution function. Before that, we'll see one example. So these three examples will definitely give a complete idea regarding these three terminologies. Consider a dice. It has a 6 face. Faces are numbered from number 1 to number 6. When it is thrown, when it is rolled, so it is a discrete probability. I have drawn here a graph by saying the probability of getting the events, they are in a discrete form. The reason is it has a 6 face. When the dice is thrown, the result is once. A result is only one, either number 1 or 2 or 3 or a 6, right? So those probabilities are considered as a discrete probabilities. The values are available at instant. That's why such throwing a dice, getting the probability is a discrete probability here. So discrete probabilities can be analyzed using the function called a probability mass function. We have said it already. The probability mass function, a PMF, it is totally related to a discrete probability. Getting the probabilities using a dice, it is a discrete probability. Analyzing such a distribution is called as here the probability mass function. And I have drawn a graph here. These x-axis, they are the events. Getting a number 1 when it is thrown, getting a number 2 when it is thrown, and so on. Getting the number 6 when it is thrown. These are the possible outcomes when the dice is thrown. Then what is its probability? What is probability definition? The probability is means the possibility. It is the ratio of event to the sample space. The sample space means the total outcomes of the process. What are the total outcomes of the process? Throwing the dice, it is 6 numbers from 1 to 6. Then what is the getting the event? Define the event. Getting the number 1. Getting the number 1 is the first event. What is its probability? 1 by 6. Similarly, event number 2, getting the number 2 when the dice is thrown. What is probability? Event divided by sample space. So out of 6, number 2 is appearing only once. So that 1 divided by 6 it is. So that it is 1 by 6. So if you consider 6 events, each probability will be 1 by 6, 1 by 6, 1 by 6. So this is called as a probability a mass function. What is probability? Event divided by sample space. Sample space of throwing the dice is 6 and getting the number 1 is an event, 1 divided by 6. Getting the event 2, it is 1 by 6. Getting the number 3, it is 1 by 6 and so on. Very good. So it is called as a discrete probability. A discrete probabilities are analyzed using a probability mass function. Fine. So next, let us draw its a cumulative distribution function. I have said cumulative means addition continuously. So let us calculate a cumulative distribution function of a probability mass function for the case study of throwing a dice. Here it is written. So cumulative distribution function, it is nothing but a continuous additions of the probabilities. See here, 1 by 6, it is nothing but 0.16. 1 by 6, it is nothing but 0.16 or else 16%. 16%. All right. So cumulative distribution function, it is what? A continuous addition. At 1, it is 0.16. At 2, 0.16 plus 0.16. At 3, 0.16 plus 0.16 plus 0.16 and so on. Then at a sixth event, it should be 1. That's the property of a cumulative distribution function. The maximum value of a CDF must be 1 and it should not be a negative number. So it should vary from 0 to 1. Cumulative, it is addition of all these probabilities, adding a 0.16, at 2 adding the one more 0.16 and so on. At the sixth event, the probability, a cumulative probability function will be 1. The meaning of when the CDF reaches the value 1, that means all possible outcomes are available and they are certain. Right? So cumulative distribution function of a given a probability a mass function is drawn here and it is varying from 0 to 1. A maximum value is 1 and minimum value is 0 and it is always increasing. We'll go ahead then. Then what is this graph? The question is calculate a CDF if a random variable x is less than or equals to 4. It may be the question for this example. They may ask when dice is thrown, find the CDF for x is less than or equals to 4. This is the question. So this can be elaborated as a probability at x equals to 1 plus probability at x equals to 2 plus probability at x equals to 3 and probability at x equals to 4. So what is probability at x equals to 1? Probability at x equals to 1 is 0.16, 0.16, 0.16, 0.16. All these 0.16 into 4 is the CDF occurring at x is less than or equals to 4. Right? Then what is the probability? What is the CDF at x is less than or equals to 6? Then obviously it must be equals to 1. So it may be a 4 or 5 or 6. It cannot be a 0 and it cannot be a more than 6 in the throwing the dice case. So less than or equals to 4, meaning of it is it has 4 discrete probabilities values. Less than or equals to 4. According to this problem, it has a 4 discrete probability of values. So all 4 values should be added to get the cumulative distribution function. So answer for this is a 4 into 0.16. What is that 0.16? So it is 1 by 6. A probability of getting each event when the dice is thrown. Right? Okay, let us consider the one more example. It is a dice, then obviously it should be related to a discrete probabilities. If it is a discrete probabilities, in your mind a probability mass function should come into the picture. I repeat, when it is a dice or a coin, those values are discrete in nature. They are nothing but a discrete probabilities. When it is a discrete probability, a probability mass function PMF should come in your mind. So let us draw the probability mass function, then let us calculate its cumulative distribution function. Alright, let us consider when it is thrown, probability mass functions are calculated here, and this is what the one experiment. It is one random experiment where number 3 and number 4 are not at all coming when dice is thrown. Yes, it is possible. When the dice is thrown, only when dice is thrown at first experiment or first trial, the probability is 1, 2, 3, 4, 5, 6. They are the possible outcomes, but 3 and 4, they are not at all coming when the dice is thrown. It is possible. It may happen at that time. So the total possible outcomes are here only 1, 2, 3, 4. Then what is the probability? The probability is 0.25, 0.25, 0.25 and 0.25. Then this is a discrete in nature. Then let us calculate its a cumulative distribution function. So at 1 it is 0.25, at 2 0.25 and 0.25 are added, it is 0.5. At 3 and 4 we are getting a 0 probability because number 3 and 4 not at all appearing when it is thrown, so that it is 0 here. So that at 3 and 4 the previous values are maintained, because to this 0.5 0 and zeros are added, so that as a result it is 0.5 and it is 0.5. At 5 again 0.25 is the probability, they are added, and at the sixth event the probability of complete event will be 1. So this is the second example. So the final value is 1, initial value is 0, and it is varying in between 0 and 1, and it is not negative, and it is not more than a 0 here, not more than 1 here. So this case, the special case is considered. So number 3 and number 4, they are not at all appearing, so that only 4 possible outcomes, so that each probability is 0.25, 0.25. So as a result, at 3 and 4 the 0.5 is maintained as it is. So if this is the probability mass function, and it will be its respective cumulative distribution function, right? So we have discussed what you mean by a probability mass function and its corresponding cumulative distribution function. We will see now. So calculate the cumulative distribution function for this case. So again the number is given, it is less than or equals to 4. then it is the addition of the 4 probabilities at 4 discrete events. So here it is 0.25, 0.25, 0.25, 0.25. They are added and result will be the same. So this is what the explanation of a probability mass function and its corresponding cumulative distribution function. Then we go ahead. We'll discuss a probability density function. What is probability density function? Probability density function, it is totally related to a continuous probability distribution. So it is discussed here. PMF, a probability which is in discrete nature, is discussed. Next, it is possible here. Probability which is continuous in nature. If that is the case, means a probability density function should be studied. So let us draw the probability density function. After, let us draw the CDF for the corresponding probability density function. All right. So let us consider example here. Let us consider the heights of the human. Let us consider heights of the human. All right. Heights of the human is written in this curve fashion, and the heights of the humans are varying from 140 to 190. A maximum height of the human is 165 centimeter. It's one real-time example is taken, and height of the human is varying from a minimum of 140 centimeter, a maximum of 190 centimeter, and a maximum height. I mean, so we don't find a human with more than 190 centimeters of height, right? So what is the meaning of this 165? Most of the human having a height which is equals to 165. Have you got the meaning of this curve? I repeat here. It is the graph which gives the height of the human, and we don't find a human with less than 140 centimeter of height. We don't find a human with more than 190 centimeters of height. And what is this peak indicates? This peak is at this peak. At the meaning of this peak is most of the women they are having a normal height of 165. Then what is this y-axis? The meaning of this y-axis is here 0.04. In terms of percentage, it is 4%. Means a 4% of women are having a height of 165. Then it is 0.01, means 1%. It is like 140, around 150 centimeters of height. Such women are available only 1%. Then what is this 190 or something here? More than 165 or 190, somewhere here it is 180 centimeter. 180 centimeter means around 2%. This is what. And you can find a human with a 165.2356 or 145.2316. Meaning of this is we are getting the human with all possible values. That's why it is called as a continuous. This graph is continuous in nature. So the possibility of having the heights from 190 to 140 to 190, all possibilities are available. That's why it is called as a continuous data. For this continuous data, the probabilities are written here. So getting 165 centimeters of a height of a human, it is what, around 4%. So can you call this as a continuous probability? So that a probability density function should be considered here. Next, let us draw its cumulative distribution function. What is cumulative? A continuous addition, increasing. See here. So if these curves are continuously added, this will be the result here. So add here. Here it is something minimum value they added. So what is the peak value here? The peak value is at this point 165. At 165 we are getting a more probability, and at 190 we are getting all possible values here. So the cumulative distribution function always reaches the value 1. It should not be more than 1 and it should not be less than 0. So always it should be increasing order. If we add all these values, we will get a curve like this. It is called as a cumulative distribution function for the corresponding probability density function. I have explained three important concepts: probability mass function, probability density function, then cumulative distribution function. Probability mass function, it is totally related to a discrete probability. Probability density function, it is totally related to a continuous probability. A CDF, it can be drawn for both the distributions. It is for a discrete event or as a continuous event. All right, so we will see a definition of the we have given the conceptual diagram and conceptual meaning of the cumulative distribution function. Let us define it. A CDF of a random variable x is the probability that a random variable x takes a value less than or equals to x. So mathematically it can be written as a capital X of x, and it is what a probability. A is an event, so that A is converted into a real number x using the random variable. It is what just a notation. It is just a notation. Either you can use fx of x or this one or this notation. They are one another same. So all these mathematical expressions gives the definition of a CDF here. It is either you can write a CDF or these mathematical symbols. They are one another same. So outcomes A in S such that their observations in Sx are less than or equal to the independent variable x. Here the small x is an independent variable, A is an event, and it is for event a real value is assigned using the random variable x, and we are drawing the cumulative distribution function. Right? This is the simple definition of a cumulative distribution function. And for a CDF you must use uppercase letter, that is F, and a subscript capital X. You can find here two things here. One is a capital X, another one is a small x. So capital X indicates a random variable and small x indicates a independent variable. Uppercase F should be used for the CDF. A subscript X is the CDF to a specific random variable. It is capital X is a random variable. F of x is what a CDF of a random variable x. You can use different terminologies. Instead of x you may use other uppercase letters U or Z and so on. So let us see a few properties of a CDF. The first property, CDF is bounded between 0 and 1. Already it is discussed. So minimum value of f of x is 0 and maximum value is less than 1 or equals to 1. It's the first property. Then second property, if the independent variable x equals to infinity, so independent variable x equals to infinity, then a cumulative distribution function should be equals to 1. The meaning of this is there is all possible outcomes are available. When the CDF reaches 1, only when all possible outcomes are available here. 1 by 6 plus 1 by 6 plus all 1 by 6 are added when it reaches, only when all possible events are happened. So that fx of x of infinity is the probability of the observations are less than or equals to infinity, which of course certainty. Meaning of this is we know all possible outcomes. All possible outcomes are happen. That's why the CDF reaches uh, unity. So you can use a P of S, or else if it is a capital X, it is not a small x, it is a capital X and it is infinity. The meaning of this small x is reaches to infinity means what? All possible outcomes are available. All right. So the third property, x equals to minus infinity. The meaning of this is impossible event. The meaning of this impossible event is we don't get a number 7 when a dice is thrown. We don't get simultaneously number 3 and 4 when a single dice is thrown. So these are what? The impossible events. From that process, we won't get the result. We don't get the a proper result. That's the limitation. Such things are called as here the impossible events. Such possible events are called as here the impossible events. So in CDF, if x equals to minus infinity means we are not getting any expected outputs. So if the independent variable is minus infinity, the meaning of this is impossible event. We are searching for the impossible events. For such impossible event, the CDF will be 0. Keep that point in your mind. Next, the fourth property, a CDF must be monotone, a non-negative and a non-decreasing. Keep that point in mind. Monotone means a single tone, a continuous. Non-negative, we have already said it cannot be a negative. And non-decreasing, it cannot it won't decrease its value. It maintains either the previous value or some value is added to the previous value, and it cannot be decreasing, right? So the pair of independent variables, let us consider x1 and x2, are chosen such that x2 is greater than x1, then PDF will be x2 minus x1, so that you can write this one. So let us find out the CDF in between 3 and 4 and 5 and 6. So only specific area is considered at that point. At that point of time, the CDF can be calculated by subtracting the larger value minus a smaller value. So that these four explanations are the properties of the CDF. The first one is it should be varying from 0 to 1 for a possible or a certainty. For certainty, the CDF will be 1. For impossible events, the CDF will be 0, and a CDF should be monotonic, non-negative and non-decreasing. And if you want to calculate the CDF between the two specific reasons, then it is what? The larger value minus a smaller value. These are the properties of a. It may be asked in the examination, define the cumulative distribution function and explain its properties. The first one, it is varying from 0 to 1, and for certainty its value is 1. For impossible events it is 0, and it is non-decreasing, monotonic and non-negative. And if the CDF between the reason is asked, then it can be obtained by a larger value minus a smaller value. And always the CDF is denoted with the capital X, and these are the it is the capital X here. By mistake it is small x here. It is a capital X, it is also capital X, and here it is a small x. It is independent variable and it is a random variable. All right, so make a correction here. Here it is a capital X. All right, so quickly we will see three examples of a CDF here. One is a continuous CDF, another one is a discrete CDF, and it is mixed one, continuous and a discrete. So continuous CDF, see here, and it is a discrete, and here it is, see here. it is non-negative, always it is positive value, the monotonic and non-decreasing. You can see here the value is maintained as it is, or either it is increasing. So for a random variable u, for an event u, the CDF is always increasing or not decreasing, and it is not a negative. So, and it is monotonic. All properties are satisfied for all these curves. It is a continuous CDF and it is discrete CDF, and both continuous and a discrete CDF. That's why it is called as a mixed one. All right. So you should be able to write these examples. Then quickly we'll see a probability density function. So a simple definition for the PDF is, it is the derivative of a cumulative distribution function. A derivative of a CDF is called as a PDF, and it is written as small f x of x. The difference is, if we use a capital F, it is a CDF. If we use a small f, and it is a PDF. And what is the definition of a PDF? It is the differentiation of a CDF. Differentiation of a CDF is nothing but a PDF, or else integration of a PDF is nothing but a CDF. They are one and the same. So instead of X, you can use any uppercase letters like U, V, Z, and so on. So PDF and CDF are inverse of each other. I have said it already. CDF, it is the PDF, it is the differentiation of a CDF, or else it is the a CDF, it is equals to a differentiation, sorry, integration of a PDF. They are inverse of each other. Differentiation of a CDF is PDF, else integration of a PDF is a CDF. They are one and the same, inverse of the each other, right? So quickly we'll see the properties of the probability density function. So it should be a P, a probability density function. A probability density function is non-zero for all values of x. So it may be a greater than 1, but it cannot be a less than 0. The first property. Second property, area under the PDF curve is equals to is equals to unity. So integration is always used to calculate the area under the curve. So always the area under the curve of a PDF is always 1. Keep that point in your mind. Then third property, a CDF is obtained by integrating the PDF. It is already discussed. The third property. Then fourth property, the probability of an event means they have asked us to calculate the PDF between the two events x1 and x2. That can be done according to the similar manner how we have done in the CDF. It is the reason between smaller PDF minus larger PDF that can be done here. So simplification. So definition we know. So it is the PDF between the two curves. So PDF between the two curves can be obtained by integrating the CDF larger value minus integrating the CDF a smaller value. So it is nothing but fx of x and fx of x 1, larger value minus smaller value. In general, it can be written as integration over x1 to x2 fx of x dx. All right, keep this definition in your mind. It is very important as the problem point of view. It is the fourth property. Then in general, we have considered a same point with a small increment, a delta x. A small increment, a delta x is considered. So at that case, this will be the a formula here. This is the fifth property. You just keep these points in your mind so that they should be applied while solving the problems. And probability density function at the same point, x and x, probability density function at the same point, it is always 0. Keep that point in your mind. So a probability density function can be written separately. Here it is asked as x is less than or equals to x. It can be written as a summation of x at equals to x and x at less than x, means this symbol can be separated here. So these are the properties of a PDF. So 7 properties. So in notes they have given, do not worry, but this fourth property is very important, though keep that point in your mind.